Hello! Here's a dynamic version of a problem situation we've looked at a couple times in class. The first time was with the take-home problem I gave you a few weeks ago, and then a variation on that problem as a bonus question on test number 1. Situation is we have a parabola, y equal x squared, vertex at the origin, symmetric to the y-axis, and I've chosen a couple points at random on the parabola. I've labeled those A and B. And then I've created the tangent lines at each of those points. A has tangent line y equal g of x. B has tangent line y equal h of x. And I've constructed this so that the region between the two tangent lines and the curve, again, this is a situation we've explored before, is highlighted here in orange. And I've also divided that region in half. One thing I noticed when we solved those first two problems, the take-home problem and the question on the test, is that the region ADC that I have here and the region BDC seem to have the same areas. Our task in those two earlier problems was to calculate the area between the parabola and the two tangent lines. And so I wondered, my goodness, was that just coincidence? So I created this sketchpad drawing which lets us manipulate points A and B, and those areas, you can see them changing here, but they stay the same. That is, each of them are identical. The area changes, but the area of one part is equal to the area of the other part. And so, is that coincidence? It doesn't seem to be. This sketchpad drawing isn't proof that those two areas are the same, but it certainly provides you some evidence of that. And of course, you can get as close to each other, those points A and B, and the region's area decreases considerably, but still we have 1/2 and 1/2. Those two areas are the same, and so we add those together to get the area of the entire region. So this is the next problem. For a parabola with 2 points chosen at random on the parabola and the tangent lines drawn in, prove in general what we seem to be showing here, that the area of this region is composed of two areas that are each equal to each other. The area of ADC and the area of BDC are equal to each other. Your job is to prove that in general for the parabola and points A and B chosen on the parabola, tangent lines y equal g of x, y equal h of x. Go for it.